So normal distribution table, type 3, z-scores. So in these questions here, what's happening is we're basically applying what we've done with our normal distribution tables, and we're putting it into context. So what we're going to be given here are x values, which then have to be converted into z values, which we can then use the normal distribution table to work out the probability of getting certain values. So here we have a question which we looked at already, but this time it's going to be in terms of the normal distribution table. So we're given the chest measurement for teenage male customers for t-shirts may be modelled by a normal distribution. So that's really important. We're told that the underlying distribution is normal, and we're given a mean value of 101 centimetres and a standard deviation of 5 centimetres. So if we were to draw a graph representing that, we would have the normal distribution, and the mean would be 101 centimetres. We would then have plus 5, so one deviation away would be 106. If we added another 5, so 2 deviations away, we'd have 111. And if we added another 5, we'd have 116, which would be 3 deviations away. If I then went 1 deviation below, we would have 96. So we'd have 96, and if we go 2 deviations below, we would have 91, and if we have 3 deviations below, we would have 86. So of course they can be written then as your z-scores, where this would be 0, 1, 2, and 3, minus 1, minus 2, and minus 3. Or of course your mean plus 1 deviation, plus 2 deviations, plus 3 deviations, and your mean minus 1 deviation, minus 2 deviations, and minus 3 deviations. So I don't have room to write in there the mean plus 1, mean plus 2, mean plus 3, okay? So now we have an idea of what our graph looks like. We're going to now look at the question. So the first thing it wants us to do is find the probability that the customer will have a chest measurement of less than 103 centimetres. Okay, so what that is saying is the probability that x, our variable, is less than 103 centimetres. So of course I can't use my tables for this. I need a z-score to represent that. So first thing we have to do is find the z-score. And to find our z-score, we use our formula z is equal to x minus the mean over our standard deviation. So we have our x value, in this case, is 103, minus the mean we have written down up there to the right is 101, over our standard deviation is 5. So that then gives me a z-score. That then gives me a z-score of 0.4. So if I sketch my graph to show what this is looking like, well, a z-score of 0.4 is just to the right of my mean, and I'm looking for less than that value. Okay, so that's what I'm trying to find. So therefore, the probability that x is less than 103 is the same as saying the probability that z is less than 0.4. So if I go to my tables and I look for my z-score for 0.4, well, that gives me 0.6554. So males with a chest measurement of 103 centimetres is basically represented by 65.54% of the customers. So for part 2, we're looking for 98 centimetres or more. Sorry, actually, if I just go back to that, I had written down step 1 there was find the z-score. Step 2 is draw your graph. And then step 3 is to look up your tables. So for the next part, so So you use your normal distribution tables for step 3. Okay, so we're going to do that each time in these questions. So we'll find the z-score, draw the graph, use the normal distribution tables then to find our probability. So here we're looking for 98 centimetres or more. So we're looking for the probability that x is greater than or equal to 98 centimetres. So again, we don't have 98 centimetres on our normal distribution tables. So we have to first of all work out our z-score. So our step 1, find the z-score. So we have z is equal to x minus the mean over our standard deviation. So if I'm inputting my values in there, I have 98 minus 101 over 5. Now again, if we go back up there to the table that we sketched at the start, we can see that this is going to lie to the left of our mean, which we know is going to give us a negative z-score. So we have z is going to equal, in this case, minus 0.6. So my second step then is to sketch our graph. So we can see what's going on. So if I look, well, there's my mean, so minus 0.6 gives us this value here. So therefore we now have to use our normal distribution table to work this out. Okay, so we have the probability that x is greater than or equal to 98 is the same as saying the probability that z is greater than or equal to minus 0.6. So of course we can't get greater than or equal to minus 0.6, so that would be the same as saying less than sorry, I've just sketched the graph wrong there. Let me just go back. So because it's greater than, my graph should be sketched greater than minus, so minus 0.6, greater than is to the right of that. So of course that's going to be the same then as saying 1 minus the probability that z is less than 0.6. And if we go to our tables, we end up with 1 minus 0.7257, which gives me 0.2743. I just want to have room there on that, okay? So we have 1 minus 0.7257 from our table. So 0.6 from our tables. If we just go back up, 0.6 is 0.7257. So if I subtract that away from 1, we end up with 0.2743. Okay, so the third part of the question then says between 95 and 100 centimetres. So let's go on to the next page. So again, our first step is to work out our z-scores. So we have 2 z-scores to find this time. So we're going to have z is equal to 95 minus 101 over 5. So z is equal to minus 1.2. And then our second z-score is 100 minus 101 over 5. And again, this is less than our mean, so we're going to end up with 2 negative z-scores here. So therefore, if I draw my graph, well, what is that going to look like? Well, minus 1.2 is over here to the left, and minus 0.2 is also on the left-hand side. In other words, they're both on the negative side of our graph. So that's what our graph is going to look like. So we then need to write this out then as an equation so we can use our normal distribution tables to work out our probability. So So in other words, the probability that 95 is less than or equal to x, which is less than or equal to 100, is the same as saying the probability that minus 1.2 is less than or equal to z, which is less than or equal to minus 0.2. So of course, that's the same then as breaking that graph down into two parts, where we would have the probability that z is less than or equal to minus 0.2 minus the probability that z is less than or equal to minus 1.2. So in other words, that graph broken down, minus 0.2 minus 1.2. So by subtracting those two graphs, we end up with what we're looking for. So of course we can't get less than or equal to minus 0.2 from our tables. So that's the same as saying 1 minus the probability that z is less than 0.2. And again, we can't get z less than or equal to minus 1.2 either. So that's also the same as saying 1 minus the probability that z is less than 1.2. So getting rid of our brackets then, we have 1 minus the probability that z is less than 0.2 minus 1 plus the probability that z is less than 1.2. So our 1's cancel there, leaving us with the probability that z is less than 1.2 minus the probability that z is less than 0.2. So if we go back to our tables, we're looking for 1.2. I'll erase the last one. So 1.2 gives us 0.8849 minus probability that z is less than 0.2. Well, 0.2 is 0.5793. And if I subtract 0.8849 and 0.5793, that gives us 0.3056. So in other words, 30.56% of the customers will have a chest measurement between 95% and 100, or not 95%, 95 centimetres and 100 centimetres. So in other words, i.e. 30.56% of customers have a chest measurement between 95 centimetres and 100 centimetres. So the last part of the question says, well, if there's 80 customers, how many of them will lie between this range? So if there are 80 customers, we would get 30.56% of 80 customers, and that would give us 24.448. Now we can't have 24.448 customers, so therefore we would say there are 24 customers with the chest measurement in the interval of 95 centimetres to 100 centimetres. Okay, now if we were to round that up to 25, say, then you'd have 25 customers. Well, 25 customers would actually give you 31%. So 25 over 80 is 31%, and that's outside of our range. So it has to lie within the range of 95 and 100. So therefore we have to actually go with the lower value of 24 customers. Okay, so just as a summary there, when we're looking at these equations, if we have the probability that z is less than or equal to minus some z-score, well, that's the same as saying the probability that z is greater than or equal to that value, which is the same as saying 1 minus the probability that z is less than that value. Okay, so when we have less than or equal to a negative z-score, that's the same as getting 1 minus the probability of z less than the positive of that z-score. The second thing to note is that when the probability of z is greater than or equal to a negative z-score, well, that's the same as saying the probability that Z is less than or equal to the positive of that value. Okay, so just two things to note there.